Hello and welcome to the 19th video that I'll be posting in my Unity platformer tutorial series. And in today's video, we will be actually discussing about player hurt animation. As you can see, if I click play right now, the player is actually not affected by the frog at all. And we are going to change that by adding the hurt animation. So what we're gonna do is we're gonna first of all create the hurt animation itself. So as always, I'm going to ask you guys to do this as part of a challenge because you've done so many challenges with animation. This should be easy for all of you. So pause the video right now and try to do the challenge. Okay, so if you did successfully do the challenge, good job for all of you who can do this by yourself. But if you don't know how to do it, it's fine. It's part of the learning process. And what you're gonna do is you're gonna go to Sunnyland and click on Windows here. Click on the animation section, animation, or click Control 6 for easier access. Go to the artwork, go to the sprites, go to the player, and go to the hurt animation here. And as you can see, the hurt animation is preset by Unity to 100 pixels per unit, and we're going to change that to 16 as always. Click apply. And once we've done that, we can drag both of these images inside our animation window. Once we've clicked on the player, click on the arrow here, click on create new clip, save it in our assets, in our player animation specifically, type in the name of the animation, and that's going to be player hurt. Once you've done that, click on the player hurt 1, shift player hurt 2, drag all the images and separate them into preference. And I like to keep it 5 pictures for every second. So yeah, that's okay. Or I could make it like around 8. Yeah, that's okay. I'm gonna close the window, go to our animator, click on our player to make sure that we are selecting our player's animator, go to our player hurt, and we are going to make the transition. But before we start making the transition, I would like to edit our script so that we can have a player state of hurt. So I'm gonna go to our assets, go to our scripts folder, click on player controller script, and we're gonna add a new state, and that state is gonna be called hurt. So I'm gonna scroll up to our enum state here, and I'm going to add a new state that's gonna be called hurt. Okay, now once I've done that, I can actually add our transition for our player hurt. So player fall can go to our player hurt, player jump can go to our player hurt, player run can go to our player hurt, and player idle can even go to our hurt. And this can be done by adding our condition, and that the state is equals to 4. And then player jump state equals to 4. State equals to 4. Finally, player idle, and then state equals to 4. And player hurt can go back to player idle, and that will be state equals to 0. And then idle can go to each other part, so it's really simple to just connect hurt to idle instead of connecting all of them. And then we are done with that. And now what we are going to do is we are going to go to our void update and add a new if condition. So instead of saying player movement always, I want to restrict the player's movement when the player is hurt. So if player state is not equal to state dot hurt, then we want it to execute player movement method. Meanwhile, if it's hurt, then we don't execute player movement. So this is how we disable the player movement from updating once per frame. And And by doing so, this means that our animation state here won't be executed per frame. And we actually want this to be continuously executed. And adding this code here means that if it's hurt, if it's in the state hurt, then player movement won't be executed. And this isn't good for our animation state. So what we're gonna do is we're gonna delete this or move this into our void update. So to do that, we can just underline all the code, Control X, which is essentially like copy and delete. And then what we're gonna do is we're gonna go to our void update, click enter below, and then Control V. And then you should paste the previous code in the void update. By doing so, our player movement can sometimes be not executed because of this condition right here. If it's state or hurt, we are disabling our player movement, and then our animation state cannot be disabled because our animation state will change back the state or hurt to idle. Or if we don't actually have this animation state, then it will be disabled too in our player movement, and basically the player will be stuck in the hurt animation. So yeah, we don't want that. So we're just gonna move that to our void update, and then we are done with our void update here. And then we go down, and we actually do not change anything in our player movement. In our jump method, we also don't change anything except our animation state. We are going to add a new animation state, and that is used or found here, and it's going to be else if player state equals to state dot hurt. Then we want to make sure that if player RB, or the velocity of the player, specifically the X, because it's going to push, because the enemy will be pushing us, will be 0.1 f, will be less than 0.1 f, which means that it's almost basically not moving. Then we're going to say that player state will go to state idle. And the reason why I want to do this is because we are disabling when we are hurt, we are disabling the movement so the player cannot move actually. And the only way the player can move is when the velocity of X of the player is less than 0.1 f, where it's essentially not moving and it's going to go back to idle. And then since it's idle, our player movement can be enabled once more, because this exclamation point here means not equals to states are hurt. So any other state except states are hurt will allow player movement to be called once per frame. So yeah, and this is actually a smart way to do it because we are trying to disable and enable the player movement. And yeah, and this code here, if I don't put this if condition right here, then once it goes to hurt, then it goes directly to idle, and basically you can't see the hurt animation. So this is the way we are trying to tell the computer that you just have to wait until the velocity of the X of the player is less than 0.1, where it's basically staying, and then you can actually make it to idle back, and then idle can allow player movement to go once again. Now, what I like to do when I'm calculating velocity is trying to calculate this by using mathf.absolute, so that we can get, or the computer will get the absolute value of our velocity, so that it will reduce miscalculations. And then we are done with what we are going to be adding in our animation state, which is good because now we can actually start programming our collision, where our player is actually colliding with the enemy. And this can be done by typing in this new method that's actually created by Unity 2, like our private void on trigger. It's going to be private void on collision enter 2D. And the first thing that we're going to do is I'm going to explain to you what is on collision enter 2D and what's on triggered enter 2D. So on trigger enter 2D is when the player collides with another object that has on trigger on its collider. And by selecting its trigger, it's basically going to be a part of a trigger where when the player enters the box collider zone, it will trigger something, okay? Meanwhile, on collision enter here means that the box collider of the other object cannot be an is trigger, and it's more to where our other object will use box collider as something that collides with the player and can bounce off the player in opposite direction. And that is on collision enter. And as you can see here, we use collider 2D and collision. In this case, we also use collision 2D and collision. And what we can do is actually we can replace this word keyword collision here with something else like other. And by replacing other, we're essentially telling the computer that other is the other game object. And it's really hard to say how other is the game object, but you will see it in a second when I start programming. Okay, so let's just refer other as our other game object, okay? And then we can just type in if, and I'm gonna create a new condition, and that is using a tag like our cherry here. If enemy, if object collision has a tag of enemy, we want to create script communication. Create script communication, which I will explain in a second. So let's just focus on the now, and it is our if statement condition right here. So if object collision has a tag of enemy, and we're gonna make a tag real quick in our frog here, tag, and we're gonna create an add tag. I'm gonna click on a tag, and it's gonna be enemy. And now we go to our frog again, and then select that tag enemy. And then now we can just type in if other dot game object dot compare tag, and then what is the tag? It says for string name, and luckily we have that string, and that is enemy at the closing bracket for our if statement, and then we're basically done with our condition. And now this is where coding gets a bit complicated because we are going to create a script communication, and this is a new term for all of you. And the way we can do this, we're gonna create a variable. And the variable is really special, and that is because we will be taking the name of the script, and that is, and what I want to do actually, I'm gonna take this enemy death effect here for our player controller, and I want to call this method. So what we're gonna do is we're gonna type in or create a variable, and the first thing that you're gonna see is we're gonna type in the name of the script. The name of the script will be something like enemy sprite or something like that. Okay, so this is gonna be the name of the variable, and enemy sprite, and I'm going to say equals to, what do we want? We want the other object to take this value, so I'm going to say other, and then I want it to other what? Other game object, of course, and I want it to say get that component. I want you to get that component. I want you to get the enemy script, and then I want to explain to you why this is script communication. And script communication is essentially where we create a variable specifically for an object, and usually this is done for a parent script. And parent script are basically scripts that don't have like a object with where it can refer to. So it's basically a free script that nobody's using, and we can use it to any object. And this is one of the advantages of having or using a parent script. And also, the way we can do this is we create a variable, and the first keyword we're going to type in is the name of the script, the name of the variable, and then what we want, which object do we want to take that component. So we're going to say other, which is the other game object, and then we want to specify the game object, and then we want it to get component, like in our start function where we always say get component here. In our start function we always say get component, so we want it to get component, and we want to get the script. Okay, and that's it with script communication. And then we can go back and go down to our program where it's going to say if player state equals to state.falling, then we want our enemy sprite, and that is our variable here on top. We want our enemy sprite to activate the method enemy death effect, and then that's how you call a method from script communication. And then finally we want to add a jump method so we can have extra jump. And what I basically said is that if our player is in our falling state, then we jump, we can fall on the enemy, and then we get extra jump, and it's like essentially like what Mario did when he stomped on enemies. And then we're gonna add another condition where if it's not falling, or I can specify this to be player state equals to state dot running. And then let me see if you guys can know the symbol right here. So just try to think what the symbol actually stands for. And then player state equals to state dot idling. Then we want this condition to happen. And if you guessed what, if you try to guess or pay attention to my previous video, we know that this is actually referring to or in our if statement. So if you guessed it, good job. If you don't guess it, then it's fine. It is a really new symbol because I've just used it in our programming once. And this is basically trying to say that if it's in player state running or if it's in player state in idling, then we want to make sure that the player state is heard because we are not jumping on the enemy. So we are just basically running or idling, then we are heard because we must jump on the enemy to kill it. And then we create another condition, and that is if other dot game object dot transform dot position dot x transform dot position dot x, then we want to make sure that if our if the other game object is higher, which means it's in the right and we are in the left, we want us to be pushed to the left. So I'm going to type in player rv dot velocity because we want to add a force, and that's going to be a new vector2 which we are trying to create. And then I want this to be a negative value something, and then I don't want to change anything with the y because the y is staying put. Yep. And add a semicolon. And as you can see, we are using -1. And I want the 1 to be replaced with something that we can edit in our inspector. So we can just make a variable for it. And it's going to be called hurt force. Okay, I'm going to name this hurt force because I want to keep it simple and make it easy for me to understand what this variable is used for. So hurt force. And then go back down and change this -1 to the variable that I created, and that is hurt force. Hurt force. And we must create another statement, else if, and that is to replace our, and that is to, for say, if we are bigger than the other object, then we are essentially in the right and it's in the left, then we want it to push us to the right. I'm just gonna say plus hurt force and then that's it. So that is supposed to be the end of our programming part of this video, and then I'm probably gonna review that later. And if we go back to our animator here, and you can see that our animator is dead. Our animator is dead. And a simple way to restart this is go to our layout, go to our default here, click on default, and it's gonna basically restart Unity, or you can just close Unity and reopen it. And this is a bug that usually occurs when you're trying to program the animator, and it's really annoying bug, and I usually just close my Unity and reopen it again. So just make sure you save everything first. Make sure you save everything. Save this. And you close it again. And you click Unity Hub once more and reopen it. Okay, so once you reopen it, you can see that our animator is back, and yeah, everything is back and everything restarted completely. And if we click play right now, we can see that our player will get hurt. However, as you can see, our player here isn't hurt because of the hurt force here. We haven't actually add any hurt force, and we are going to actually delete a few of our animations that we created transition with. And I'll be deleting transition player run to player fall. Because player run and player fall actually, after a long decision or calculating, we do not actually have or create animations from this, and there is no purpose for it. So we are just going to delete that. We will play here. As you can see, we are actually animating into our hurt force. And the reason why I had to delete that animation right there is because player run here and player fall is not necessarily needed, and it's basically over complicating our system. And as you can see in our program, we don't even have a run go to method. If we check in our program here, all of our code here will never go to run to fall. It'll usually go to run, and it'll go to jump, and then jump goes to fall. And there is no way that it goes to run to fall instantly. So yeah, that basically crashes the program because it's gonna override, like, it's instead of, like, it's confused because it's going to go to player run, go to player fall, but it has to go player jump again. So that's why it is a little bit broken. And another thing that I want to talk about is the fact that if we jump on the enemy here, you can see that it explodes, but it's exploding forever. And it might be a cool effect here, and we do not crash it because it's in kinematic. But then it looks cool, but I actually don't want it to be like that. I want it to disappear once it explodes once. And the way we can do that is actually go to our animator here and go to our Windows animation, and we're gonna go to our enemy death effect here and go to our 25-second here and add an animation event. And we can select our enemy dead. And as you know, enemy dead, destroy game object. So yeah, so it's gonna destroy the game object once we've done that. So if I close this window right here, click on our play, jump on the enemy, and it explodes and it's gone. And we do not see the enemy any longer. So I think that's it actually. I've already programmed or covered up all the things that you need for the player hurt animation. And what I'm going to do is I'm going to review all the code right now. So for player controller script, the changes we did were the fact that we added the hurt for enum state, and that is used for adding the states in our animation. We changed our program so that the player cannot control the movement until the velocity is less than 0.1, and at that point we are actually idling already. And then it can allow us to move once more. Animation state must be out of player movement because we want it to always run per frame or update per frame or call per frame. So we're gonna move it to the void update because in our player movement it has a condition now, and if the condition is not fulfilled, then player movement will not be executed, and that means that it's not always call out once per frame, and we need animation state to be called once per frame, or not. Once the state will be hurt, the player movement will be not executed anymore, and the player state will be stuck at state or hurt because animation state cannot be executed. As you can see, animation state is the one that returns it back to idle. And then this code right here is also executed, needs to be in void update because this is the one that actually allows us to connect our animator with our programming. If we don't have this, we can't actually change the state. And then we didn't change anything in our player movement. We didn't change anything in our jump movement. What we did actually change is add an animation state where we want it to change back from our hurt animation to our idle. And to make sure that we are actually idling, we make sure that our velocity x is less than 0.1 f, and at that point the player should already have returned back to idle. And then we change or added a new method called onCollisionEnter. And instead of having our collision here, I changed this to other. And this means that I can say if other, and I'm referring other as the other game object. So other.game object, and then we want to make sure that we compare the tag enemy, because we can't just say if other is, if other, for example, it's going to be another animal and we don't have the compare tag enemy, then we don't know which enemy it is, right? So for example, it's not even enemy, it's just a box, and it has onCollisionEnter. It's not trigger, it's just a collision. It has a collider. And if we don't say the tag, then we might get hurt by the box itself, even though we don't want our player to be hurt by a box, right? So that's why it's really important to have a tag so that we know which objects we want to specify clearly. And then this code right here is script communication, and the way we can type in script communication is name of script and then name of variable. Wait, let me just add like script and then comma space, okay, name of variable, and then comma equal to comma the object you want to take the script, and then we want to say get component because we want to choose which component we want to get, and then name of script brackets, and then as always semicolon. So that is how you write your script communication. And then we have our statement here, our new statement. And this statement is essentially for killing the enemy, and that is by making sure that our player is in the jump state. And if it's in jump state, it jumps on the enemy, it goes to the enemy sprite. We are calling this variable because we want to get the enemy script method enemy death effect. So we're gonna call in this variable and then dot enemy death effect, and this is already assigned to our other object because our other object already takes the component. So enemy sprite dot enemy death effect, and then basically the one that we say is for our frog. So our frog will die, and then we get an extra jump because we want to jump higher a little bit. So we're gonna get jump method, and then we have this statement, which is the opposite statement for this, or the counter or the opposing condition for this. So if it's not falling, then it's obviously running or idling, right? And if it's idling or running, then we want it to be hurt, because if you touch the frog where you're idling and running in Mario Bros. Or in Mario games, they just get damaged. And to show that, we just say player state equals to state.hurt, and then this statement here, if and else if here, is to give the force. We either want it to go left or right. And the way we can check it is if the other game object position X is larger, which means that if we can see here, if we go to our player here, so let's just say this is the first point 55, and then if we move the player a little bit to the left, we can see that it's 51. So if the other game object is larger than the player, then it's basically 55, so it's in the right position, and our player is in the left. Then when we touch it, then it's basically asking our player to go to the left, or pushing our player to the left. And then if it's the opposite, then of course the player, for example, the point is 51, and this is our enemy, and our player is in 53, which means that our player is in the right, and our enemy is in the left, and then when we crash it, we want our player to go to the right. And that is essentially what this code is actually doing. So I think that's it for me today, actually. I think I've covered up everything. I've reviewed all the code, and I hope you guys understand more about this and keep practicing on this script communication. It's pretty advanced, and as long as you get the logic behind it, it should be kind of easy, because you don't need to remember all of this. You just need to find the logic behind it. And I hope this is really helpful for all of you guys, and I think that's it for me today. I hope you guys enjoy this video, understand more about Unity platformer making, and I'll see you in the next video.